All right, we're in lesson 12.5. So more factoring like 12.4, except in 12.4, we didn't have a leading coefficient here on the variable that was squared. We had a coefficient of 1, so there was nothing there. It would just say x squared. So now we're going to look at factoring these when there is a coefficient there in the a spot. We know that's a, b, and c. So instead of a 1 in front, we've got something else. So two different types of problems that we can see here. One like this, where there actually is something that we can just completely factor out from all three terms to start with. And then there's going to be times that we can't do that, and we still have this leading coefficient. Okay, so let's start here. I see a 6 here, a 6 here, and a 36. I also see an x in every single one. So I can go ahead, just like I did in chapter 11, and factor that out completely. So not even going to binomials right now, just going ahead and factoring something out, the common factor for all three of these terms. So 6 goes into all of them, and I have at least x squared in all three of them, so I can take that out as well. So let's work backwards and see what we would have. So to multiply to create a 6x to the fourth, I don't need another 6. All I would need is an x to the second. So this times this would be 6x to the fourth. Then I'll have a negative. Again, I don't need a coefficient to get to the 6, just a 1. To get to an x to the third, I just need an x. So check it again. 6x squared times negative x would be negative 6x to the third. And then now to get to the negative 36, I am going to need a leading coefficient of negative 6. I've already got the x squared. I don't want any more here, because if I added any more x's, then I wouldn't have x squared. Okay, so I have factored out 6x squared. Now, we've done that before, but here's where we're not done anymore, because this now, forget the 6x squared, this can be factored just like we did in 12.4. If we take a look, I have this number here of negative 6. I'm going to think about the factors of negative 6. So let's just think in positive numbers for a second. 6 and 1 and 3 and 2 are my only combinations to make a 6. Now, since it's going to be negative, I know one of these are negative. So it could be a negative 6 and a positive 1. It could be a positive 6 and a negative 1. Negative 3 positive 2 or positive 3 negative 2. Now they have to add up to a negative 1. So any combination of 6 and 1 isn't going to get us there. So those are out. And now I need to choose the right combination here. If it's going to end up negative, that means I need more negatives than positives. This would give me a positive 1 when I add them. This would give me the negative 1. So here's my correct combination. So this becomes x minus 3 for the negative 3, x plus 2 for that. This 6x squared is still going to sit out front. You could always double check this. There's your x squared. You're going to get a 2x and a negative 3x. That's a negative 1. That's what we talked about here. And then when you multiply, we know that they are factors of negative 6. So we will also get that. Now this is completely factors. So sometimes we're going to start off with something that can be taken out of all three terms and then be left with something that can be factored further into binomials. That's not always going to be the case. So factors of 5 is just 5 and 1, and that's not going to fit into these. 1 will, obviously, but 5 does not. Okay, so we can't do that first step. So here, we're looking to go directly into the binomials. But where this is different now than 12.4 is we don't just have x times x to create that first term. X times x would be x squared. Well, I have a 5 there. So when these two got multiplied together, we ended up with a 5x squared. Now, this is a simple one because 5 could only come from one simple whole number multiplication, 5 and 1. Right? There's no other combination of whole numbers that multiply together to make 5. We'll look down here where there's going to be actual other combinations we have to worry about. But in this case, I can go ahead and put the 5 right here because when I multiply this times this, I'm going to get 5x squared. And that's the only way to do it. All right. And since I have positives all the way across, I also know that these are both going to be plus. So we're going to go through the same process of finding factors for this number. So 12 and 1, 6 and 2, 4 and 3. But it's a little bit different because we're not going to simply say, well, can a 4 and 3 make a 32? 6 and a 2 make a 32? 12 and a 1 make a 32? Well, none of them do. And here's the trick. Before, you look at this one again, the reason that worked, were these directly related to the middle term, is because this one was times by just an x, and this one was times by just an x. And so the coefficient was 2x and negative 3x, and then they combined. Well, up here, this number gets times by a regular x, but this number gets times by a 5x. So one of these two factors, whichever one's correct and lines up in this spot, is going to get times by 5. And then this one's going to be times by 1. So you could try these out. So like this one, if you times this one by 5, you'd have 12 and 5. Do 12 and 5 make 32? No. You could times this one by 5. So all of a sudden now you'd have 60, and 60 and 1 is not going to make 32. So I can eliminate this. The other way, you could go through the whole process like that until you found the right answer. Or you could start plugging in numbers and just see if it works, like a 4 and a 3. If I did that, so of course I'd have 5x squared. I'd end up with a 15x from this one and a 4x from this one. Sure, I'm going to get positive 12 when I multiply here, but the key is how do I end up with a 32x? And 15 and 4 ain't going to get the job done. Okay, so that's not right. Well, what if I did the same combination of factors, but I just switched them? I haven't necessarily eliminated the 4 and 3 yet, because what if they went this way? So of course I get 5x squared. I'm going to get a 20x from this and a 3x from that, and then of course the 12. So the first term works, the last term works, but these two together don't make 32. So now I've eliminated the 4 and the 3. So the only options now is the 6 and the 2. So let's, before we start writing this all out, think about it. One of them is going to get times by the 5. The other one will stay the same. They need to add up to 32. So if I did this one times 5, I'd have 10. 10 and 6, not going to make 32. So that's not it. What about this one times 5? 6 times 5 is 30, plus the 2 is 32. So that's the combination. The 6 and the 5 need to be multiplied together. So the 6 needs to go in this spot, so it does receive the 5. So I know I have a 5x and an x, and it's 6 and 2, but I got to put the 2 here, so that only interacts with the x. These two never get multiplied, right? If they're in the same set of parentheses, they never get multiplied. So the 2 needs to go here. The 2 is not times by the 5. The 6 is out here. And this is your final factored form. And of course, you can double check it. Multiply this times this, that's 5x squared. This times this, that's 30x. This times this, there's the 2x. There's your 32x. And then, of course, this is plus 12. So we are good. So it's a little bit trickier. We now have to think about one extra little step where this number out here is going to get multiplied by 5. All right, down to example 3, I would take it up even one more level, because up here we knew that it was going to be a 5 and a 1 up front, because that's the only way to make 5. Well, now we've got 15. So we've actually created a whole bunch of other options here. So we're going to do this one by actually writing them all out and then figuring out which is the correct one. And then as you get better at these, you can kind of do it in your head a little bit. So we know it's not just y times y, because we ended up with a 15. So combinations, it's 15 and 1. We know that. Or it's 5 and 3. So either I have a 15 and a 1, like that, or I have a 5 and a 3. Both of those could work to create this front part right here. Now this one is nice because I'm dealing with a 7 out here. There's only one way to make a 7 through multiplication. 7 times 1. Now one of them could be positive and one of them could be negative, so we do have to think about that. But other than that, we're only going to have to deal with that. So we know that this is either a minus 7 and plus 1 like this, or a plus 7 and a minus 1 like this, right? That creates a negative 7, that creates a negative 7. We'll test the rest out in a second. We're going to write them all out for this one, which you don't have to do every time. And we could also switch locations here. We could put the 1 here and a negative 7 here, or we could put a negative 1 here, a positive 7 here. So again, let's break down what we've got here so far. All of these are going to create a 15y squared up front. all of these are going to create a negative 7 at the back. We're hoping one of these creates a negative 16. So before we go on to the other possible combinations, we might already have it here. So let's check it out. Again, we don't need to recheck the front term. We know it's going to be this. We don't need to recheck the last term. We know it's already going to be this. But will it create a negative 16? So this first one, we would get a 15y and a negative 7y. Not going to create 16. We're going to get a negative 16, by the way. We're going to get a negative 15 and a positive 7. That ain't going to do anything for us. Here we're going to get a really big number and a 1. Not going to get us the 16. This would be a negative 105. And here we're going to get another 105 and a negative 1, and that's no good either. Okay, so none of these worked. So what I need to do is now the same exact thing, but over here. So we've figured out it's not going to be a 15 and a 1 up front. It's going to be something else. So these numbers here are going to be replicated because, again, we need to create that negative 7, and the only combination is 1 and negative 7. But now these are going to be different up front because we're making that 15 with a 5 and a 3. So I'm going to go ahead and go all the way down here. Now, like I said, you don't have to go through this whole process every time when you get better at this, because you can kind of just think ahead. Multiply by 15, 15 times 1, and then the 7 times 1, but we're not going to be there yet. That's going to take us a little while. So for now, we're going to use process of elimination. All right, so we've got these all set up. All of these will create a 15y squared up front. Now we need to create a negative 7 in the back. So I'm going to go ahead and follow this just to keep it consistent. A minus 7 and a plus 1, that would create a negative 7. A positive 7 and a minus 1 will create a negative 7. Plus 1 and a negative 7 in different spots creates a negative 7, and a minus 1 and a positive 7. I think if you set these up like this next to each other and just be consistent with what you're doing, it'll just make it a little less confusing. All right, so now we got to go through these. Again, all of these create the perfect first term and the perfect last term, but we haven't found one yet that creates the middle term. So we're going to have a 5 times 1 and a 7 times 3, negative 3. So a 5 times 1 would be a 5y, and a negative 7 times 3 would be a negative 21y. Add those together, and I get negative 16. And I just found my answer. This is going to work. Let's double check all the other ones here. We'd have a negative 5 and a positive 21. So that one will create a 16, but not a negative 16. And then here we're going to get a negative 35y and a positive 3y. No good. This one's no good. This one was good. And here we're going to create a positive 35y and a negative 3y, which again is no good. So this is my only option. You're going to get 15y squared. You're going to get positive 5y. You're going to get negative 21y. And you're going to get negative 7. These two will combine to create your negative 16, and you are good to go. So for now, for these, the harder level questions, make lists, and then you're just plugging everything into all your options to figure it out. It's the tedious way to do it right now, okay? But down the road, you'll be able to basically visualize this without having to write it all down and be able to get yourself kind of through process of elimination to the right answer. All right, let's flip to the back. So the front was all just how do you factor it. Now we're going to actually solve it by factoring. And so I'm missing something here on the notes. Can't solve this unless it's an equation. This should say equals 0. So your copy may already say equals 0 if I fixed it, but mine didn't already have that. So we're going to solve this equation now. So we did this in 12.4. We factored, and then we figured out what was the number that made the equation true. So first thing we got to do is factor. All right, so for these style, when we have this 3 up front, first thing we should check and see, does anything factor out of all 3 of these? And the answer is no, because 3 doesn't go into all of these. They all don't have an x. So nothing I can take out of all of them. So I'm going to have to split this into separate things. And this is a nice one because it's a 3 up front. And so the only way to make a 3 is a 3 and a 1. There's no other combinations. Okay. Now to make an 8, I've got lots of different combinations. I've got negative 8, and 1. I've got 8 and negative 1. And I've got 4 and negative 2. And I've got negative 2 and oops, I did that the same, didn't I? And then negative 4 and positive 2. So those are your only ways to make a negative 8 through multiplication. So we just need to try those all out until we find one that works. So I'm going to write these all out. But if we find one that works before we get to the end, we don't necessarily have to go through all of them. So let's try a -8 and a +1. Let's try a +8 and a -1. Let's try a +4 and a -2. And a -4 and a +2. One of these should work. All right, so we already know the front's going to work. There's our 3x squared. We already know the back's going to work, -8. But what about my middle ones? So when I multiply out here, my x's, I'm going to get a 3x. And here, I'm going to get a -8x. So together, that's going to make a -5. That's no good. Here, I'm going to get a -3x. And I'm going to get a +8x. Okay, those together make a +5. No good. Here, I'm going to get a -6x and a +4x. That's going to create a -2. That one looks good. Theoretically, you could stop right there, but we've only got one more. Let's check it out and make sure we didn't make a mistake. Make sure this doesn't work. +6x, -4x. That creates a +2x, not a negative. So that's no good. All right, so this is my right answer. So now I'm going to go ahead and use that to solve. So bringing down my correct answer. So this whole thing equals 0. I've taken that expression and factored it and bringing it down and plug that now into the equation because they're equivalent to each other. And now I can figure out what numbers make this true. So here's your easy one. Again, like we talked about in 12.4, we're trying to figure out what numbers can I plug in for x to create one of these equal to 0, because anything times 0 is 0. So this one could be 0 or this one could be 0, and not the x, the whole value. So what number do I plug in here to create a 0? So plug it in 2, because 2 minus 2 would be 0. So I already know one of my answers here is 2. And then what about this one? That's a little trickier. What do I plug in so that I can multiply and then add 4 and get 0? So if you can't do it in your head, what you should do is separately figure it out. How do I make this equal to 0? So set it equal to 0 and solve it. So take the whole thing, equals 0, and solve it. -4 from both sides. And then divide by 3. And x equals -4/3. And if you actually ran through this again and did 3 times -4/3, you're going to end up with -4, and -4 plus 4 is 0. So for a lot of these, when you solve them, you are going to get fractions. Don't turn them into nasty decimals. Leave them as fractions. Okay, so you're going to see a lot of fractions as answers on these types of questions. Okay, last one, number 5. This one can be a little complicated because we've got the 14 up front, and we know more than one way to get a 14. So it could be a 14 and a 1, but it also could be a 7 and a 2. So we're going to have to make our list here and try and figure it out. So the good news is this only has 2 factors, a 2 and a 1. And these are both positive, and so we don't have to do negative stuff here. So we actually don't have too many lists here to make. It's either going to be a 2 and a 1 here, or it's going to be flip-flopped. The 1's going to be here, and the 2's going to be here. Same idea over here. 2 and a 1 like this, or flip-flop. So when we don't have to deal with negatives, it greatly reduces the number of things we need to try. The only way to make a 2 through multiplication is a 2 times a 1. We know they're both positive, so we know it's either a 2 or a 1 flip-flop one way or the other. For the front term, it could be 14x times x, or it could be 7x times 2x. So we've got just 4 things to try. Really not that big a deal. We know the front's going to create this. We know the back's going to create this. We need an 11 in the middle. So we're going to get a 14 here and a 2. Not going to be an 11. We're going to get a 28 and a 1. That's no good. We're going to get a 7 and a 4. That sounds good to me. That's going to make 11. And over here, we're going to get a 14 and 2, which almost sounds like it works, but it is not going to work for this. So this is going to be our correct factored form. So we are going to have 7x plus 2 times 2x plus 1. That's the equivalent version of this. So when that equals 0, we need to figure out what numbers can we plug in. So what I'm going to do is I'm going to just separately solve both of these for 0. When does that equal 0? And when does this equal 0? So minus 2 divided by 7. So x can equal negative 2/7 divided by 2. Or x can equal negative 1/2. So those are my final two answers. You can write them as a list like we did up here, or you can just circle them like this. That's perfectly fine. So if you went back and plugged in these goofy looking fractions, and I just noticed that on my copy that this should be an x. So on your copy, that should already be fixed. But if I plug these in for x, you will be good to